Hello everyone, welcome back to our channel, and today we will be working on a new question. The question is minimum parenthesis. You can see the question, it's minimum parenthesis, and let's see the problem statement. So we are given a string which is called pattern, which contains only two types of character, the opening and the closing bracket. Your task is to find a minimum number of parentheses, either opening or closing bracket. We must add the parentheses in the string pattern and result the string is valid or not. Okay, let us take some examples. Okay, so we have a sample input over here. We have two inputs. So the first input is over here, and you can see the output is 3, because if you see the imbalanced opening and closing brackets are 3. So if you see it over here, let me do it properly for you guys. Okay, the first one is an opening, but there is so the first one is the closing, but there is no opening, so it is imbalanced, so it will be counting 1. The second one is opening, but there is no closing, so it will be counted 2. Third one is the same, so total count 3. The fourth one, you can see there is opening and closing both the brackets, so the total number of count is 3. Here you can see we have two opening brackets, but we don't have any two closing brackets, hence the output is 2. You can see they even explained you over here. So in the image you can see properly, they, if you are not able to understand easily, they even give you a visual representation of them using an image. Okay, let's get started to solve the question, and let's see what approach we will be using to solve this pattern. So the first thing we already know, like whenever we don't need to count a successful let me change the pen. We don't need to count a successful opening and closing bracket, we only need to count the unbalanced ones. So if let me give you an example. So this, so it will count 3, but we don't need to count this one because it is balanced, so till it will be 3. Let's take this one. Okay, so for this one, this is balanced, this is balanced, this one is balanced, this and this is balanced, so the count, the only one left is count 1. So output should be 1. Let's take another example so you can understand properly. So in this case, this is unbalanced, 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 because we don't have any opening brackets over here, it's missing. So we have 3 till now, and this is balanced, this 2, this is unbalanced, so the count should be 4. So let's get started, and let's see what we can use. So by looking at this problem, it seems we can use stack, which is last in first out. So let's see how. So let's draw a stack. Okay, so let's take an example. Let's take this. Okay, we'll go from the 0 index, so this will be the one. So it is an opening bracket, so if it's an opening bracket, we'll push it into the stack. So we'll push it into the stack. Next we'll increment. This is an opening bracket, we'll push into the stack. This is a closing bracket, so whenever there is a closing bracket, instead of pushing, we'll pop the stack. So we'll check if the stack is not empty. If the stack is not empty and the index value is a closing bracket, we'll pop the value inside the stack. So right now it is not empty, we already have 2 elements over here, and you can see it is an closing bracket, so we'll pop this one out. So we'll pop this one out, already pop. Next we'll move ahead. Next one is again an opening bracket, so next one is again an opening bracket. We'll push it inside. Next, it is an again opening bracket, we'll push it inside. This one is again a closing bracket, we'll pop this again because it's not empty and we have already 3, so we'll pop this one out. So let's pop. Next, this is a closing bracket, so we'll pop this one out. So let's pop, remove it. So right now the only elements remaining inside the stack is 1. Okay, so the only remaining is only 1. So let's see the answers, if answers are correct. Okay, so yes, so if you see properly here, let me draw it properly here. Okay, these two are balanced, these two are balanced, you can say these two are balanced, so these two are balanced, yes. The only left is this one, so that's why count equal to 1. And we have only 1 over here in the stack, so count equal to 1. Let's try to write the algorithm. Okay, so we'll first get the length of string. So let's take as a pattern. Let's go downstairs somewhere. Okay, so we'll have a pattern which will be having these values. Okay, now let's get started. Let's use the white this pen. Okay, we'll have the pattern, and we'll get the length of this pattern first, or no need of length of the pattern. We'll be using for loop for char in pattern. We are using Python, so we will be moving by each index. So we'll be starting from 0 to the end of the string. So for char in pattern, if so, let's also declare stack. So we've declared stack if char is equal to opening bracket. We'll just push it. So we'll be just char dot append. We for pushing we use append in Python into the sorry. So this will be stack. Okay, let's take this one will be the stack. Stack will push into the stack. Great. Now another condition, else if character equal to the closing bracket. If it's closing bracket and the stack is not empty and stack not empty, then we'll pop it out and we'll write stack dot pop it out. Okay, let me explain you why I wrote this and stack not empty. Okay, let's take an example over here, and the stack is not empty. Let's take this example. We have a stack. So this is the condition. So it will come over here if char equal to this and stack is not empty. So right now there is no value inside the stack, so there is no opening bracket. So there is no opening bracket inside the stack, so it's no reason to pop out something because there is no element in the stack. So there is no logical reason to pop it out something which is not present. So we'll just count it. If the stack is empty, we'll just count it. So it will be count equal to 1. It has the same count equal to 2 because stack is empty. You can't pop anything out if there is no element in the stack. So we'll just count it 1, 2, 3, 4, 5. So answer will be our 5. So there is no reason to pop it out into the stack. So we can write this in a better way, and stack will just write this because it checks automatically, and stack, which is also meaning like stack is not empty in Python. Else if, okay, now this condition, if stack is, if we have this and stack is empty, the case which I showed it over here, stack is empty and we have this case, we need to just count it, count plus plus. So let's declare a variable count which will initialize the value equal to 0. So let's declare a variable over here, count equal to 0, and then we'll write an else which is count plus plus. So once this is done, we will be return length of stack plus count. So why length of stack plus count? Let me show you. So let's take an example with this one. Okay, so the output for this will be 2, or let's suppose, okay, yeah, let's take this only. Let's take this is our stack. We will be beginning with the 0 indexing, so this one we will be pushing it into a stack, again incremented the position, where on the second index will be pushing it into our stack. The third, till now the count value is 0, till third one. Okay, on the third one, it's again the opening bracket will be pushing it into the stack. The fourth index, we will be popping out 1, so we will be popping out this one, so it has been removed. Now we only have 2 elements and the count value is still 0, so we cannot return count. We need to get this 2 element. So for this, it's basically length of stack, which will give us 2, and right now the length of stack is 2 plus the count value is 0, which is equal to 2. So the answer is 2, and for this answer is also 2. That's why we are returning length of stack plus count. So length of stack if there is any opening brackets which are left under inside the stack, and closing, if there is under a closing bracket left, it will be counted in the variable count. So hence we are using length of stack plus count. So this is our pseudo code. I hope you got it properly. Okay, this is the pseudo code, count equal to 0, stack. Okay, perfect. So let's jump into our platform and let's try to execute this solution. Here is the code. So there is a function called minimum parenthesis, which is taking a pattern as a string. So we are just initializing the value of count equal to 0 and stack, and then we are running from 0 index to end of the index, and we are searching for an opening bracket. If opening bracket is found, we are just pushing it into our stack. Else, if there is a closing bracket and the stack is not empty, we'll be just popping the element present in the stack, which will be an opening bracket. Else we'll be incrementing count equal to count plus 1. So we will be just getting the length of the stack at the end of the whole loop, and then we'll be returning length plus count. So instead of this, we can even write let me write it over here. So length of stack. Perfect. So let's try to run the code. Okay, so all the test case have been passed. Let's try to submit and see. Okay, so it got accepted, and yes, so we have solved this question, guys. So one more thing, you can have a multiple solution for a single problem. You can even optimize this problem more further, so it's up to you. So this is only for to teach you guys that there is an approach, there is a one more approach to solve this problem. So for today, thank you so much, guys. Have a great day.